And as usual, like when I'm conducting the interview, I'm going to kind of ask questions kind of for the broader audience, because obviously a lot of people might know the intricacies of, for example, what low-level APIs or whatever do. So we'll try and keep questions, and then you can explain things better, I figure, probably.
Sure. Yeah.
So,
yeah. And you're going to post the audio?
Yes, I'll be posting it. I'll be putting it along with slides as well. So it's going to take me a few days because I'm going to edit it. So what I'll do is, obviously, as soon as it's ready, I'll hand you the link, or rather Alex, and then you'll have it, and then you can obviously post it on your social media as well.
Great. Sounds good.
All right, so we'll start out with, I guess, the first question. So I believe the last time we spoke was April this year.
Yep, that's right.
And since then, there's been an awful lot of movement with OpenGL, Vulkan, in fact, the entire Khronos group. So before we start doing an in-depth dive, do you want to give us a basic overview of what you think the highlights have been over the past few months?
Yeah, absolutely. And you're right. There's actually been a lot of progress on lots of the standards that we've been doing. So let me think. Actually, I'm going to bring up my Siggraph because I have a handy dandy list there.
Yeah, I've got that list as well. We're going to call it the cheat sheet for the rest of this interview.
Yeah, right. Yeah, I got it right here. Right. Yes. So since April, there's been a lot of on the vision and neural net side of things, and because we're finding that for many of the APIs, the killer applications are vision processing and neural net processing for things like augmented reality and virtual reality, and autonomous vehicles, cars, and stuff like that. So we actually have a kind of a cluster of the APIs that can be applied to that kind of thing. So we have OpenVX, and we released OpenVX 1.2 back in May, and that has a definite focus on bringing neural nets as well as classic vision processing into the acceleration API. And we're working on NNEF, which is the neural net exchange format. We haven't released that yet. We're expecting that to come out in version 1.0 towards the end of the year, but that is a very good complement to OpenVX because you can import neural nets into OpenVX for execution. And on the OpenCL side, which is slightly lower level, some people use OpenCL under the covers to implement OpenVX. We have released OpenCL 2.2 in May, and that brings C++ up and down the stack. And then in the Web3D conference in June, we released GLTF 2.0.
I saw that. That's very impressive. I think for one thing, if memory serves, because I didn't have a huge amount of knowledge on that particular project, but I do remember GLTF also now allows physically based rendering, correct?
Yes, that's right. And that's actually the really big thing in 2.0. Because some of the history, GLTF 1.0 was originally designed for WebGL, because WebGL by definition has to bring its assets across a network, the interwebs. And so there was a clear problem to be solved there, and that's where GLTF started. But now we have a lot of native applications wanting to use GLTF as a format to import and export 3D assets. And for those people using DirectX or Metal, they have no clue what to do with a GLSL shader, which is the way we defined materials in GLTF 1. So with GLTF 2, we don't use GLSL explicitly anymore. Instead, we define physically based rendered materials. And that means we can actually get better quality, and we're API independent. And so we have applications as diverse as web applications with WebGL, all the way through now to high-end authoring applications, and even Microsoft Office is going to be using GLTF to import 3D assets into things like PowerPoint and Word.
That's actually really cool. Because I remember one of the big things you guys were working on was OpenXR. which I don't think actually had a name back then, but essentially it was the idea of obviously having a standard where, because obviously, let's say I'm a virtual reality developer and I'm creating something in Unity, and you're a virtual reality developer and you're creating something in, UE, or someone, Bob's creating one in proprietary engines. It's an absolute nightmare, because if you're targeting to Jimmy, the customer, he's just bought an Oculus Rift. He's going to be pretty upset if his particular headset doesn't work anymore. So obviously there had to be some levels of standardization there, right?
That's right. And we announced the initial kind of portable VR initiative back at the end of last year. But at GDC, which is in February, we did announce the name OpenXR. And you're right, it's, I think, a standard for portable VR applications and devices is going to be an essential part of the overall growth of both VR and AR, virtual reality and augmented reality. And that's why we have the X, because it means AR and VR. And it's solving multiple problems, and it's a win-win. So for application developers, it means, as you say, they can write once, and they can run across many different runtimes. For the device developers, if I'm a small startup developing a innovative hand tracker, I can write my own OpenXR drivers and self-integrate into OpenXR compatible runtimes, so you get more devices. And the bottom line, though, is exactly as you say. It gives consumers the confidence that the content that they want is going to run on the device that they have, and therefore it's the right time to invest.
I think that's kind of the crux of the matter, because I was actually reading a PDF that was actually quite interesting. It was hosted by the guys who created and ported Mad Max, Feral Interactive.
Yeah.
And it was actually quite interesting because they were talking about just the levels of performance, difference that you're seeing now, which is obviously a major boon, because obviously with Linux beforehand, we're referring primarily to Linux port, you guys had they were using OpenGL. And it's quite insane, because when they just switched, obviously it does depend upon the scene and what's going on, at that particular frame, but they were talking about frame rate increases, frame time reductions of like 50 or even 100%, which is just absolutely just crazy. Obviously they were CPU bound quite often, so the GPU was just kind of like, what am I doing? I'm just kind of not doing anything. And I guess when you think about that, that's a major bonus for developers. I suppose what I'm basically getting at is, do you think this is going to really help Linux developers and people kind of porting, and for people who are, because obviously you can play games now with, on Windows games on Linux, but it's a pain in the butt. Do you think that's going to be kind of something that's going to help open up the ecosystem with Vulkan?
Yes, absolutely. I think the world is ready for the new generation APIs. It was, we kind of realized that this year that it was the 25th anniversary of the launch of OpenGL 1.0.
I forgot to mention that. That's crazy, isn't it?
So, yeah, and it's amazing. And OpenGL is going to be around for another 25 years too. So
because you guys have just launched 4.6, right?
We just evolved it to 4.6 because there's still, evolving needs for it, because there are so many developers, so many applications that use it. It's not going to disappear anytime soon. And we're not even in maintenance mode. There's new requirements coming in, and that will continue.
What was it? So, just a quick aside. What was it that you guys did with anisotropic filtering and SPIR V with 4.6? I did kind of read the notes, but I was kind of I didn't get to read all of it, to be honest. What changes have you got with AF and SPIR V with 4.6?
Yeah, so that was the two big things. There was a bunch of extensions that have been out there for a long time, and we brought those into core. Some because the technology now was well supported enough across all of the OpenGL vendors, so we could bring it into core and not disenfranchise anybody. And that's a normal part of the evolutionary process. Some of them we were able to bring in because we've wanted to for a long time. And the patent just expired because we're committed for the core specifications to be royalty free. That's one of our guiding principles, and so we can't bring it in until the patent. Either we have a royalty free license, which is the normal process. But occasionally there's a patent where one of the companies doesn't want to give it away for nothing, and so in that case we just wait for the patent to expire. In this case, OpenGL outlived the patent, which was good. So you had a bunch of extensions coming in, but perhaps the big one, the most impactful one in terms of OpenGL usage, is the fact now we support SPIR V, and SPIR V is the to remind everyone, is the intermediate representation that Khronos defines. It's similar to LLVM. I'd like to say LLVM, which is the low-level virtual machine. It's a very successful, widely used open source project for CPU compilers. SPIR V is kind of equivalent, but it's defined by Khronos. It's a spec, not just an open source project, so it's much more stable in its definition. But the main thing is it includes 3D graphics and parallel computation language. SPIR stands for Standard Portable Intermediate Representation. And the V, the SPIR V, is when we upgraded it to support Vulkan as well as OpenCL.
That's really cool.
And now we have SPIR V ingestion into OpenGL. OpenGL Vulkan and joins OpenCL. So now any language front ends that generate SPIR V can now be fed into OpenGL. For example, the community is very busy building an HLSL to SPIR V compiler, and that means for the first time OpenGL can now run HLSL just like Vulkan. So that's actually pretty cool. And that means, for the game space particularly, that because bringing HLSL into either Open or Vulkan is very enabling, because most game developers develop most of their shaders in HLSL or GLSL. Now they don't have to rewrite any of that to use GL or
It's quite interesting as well, because when you're talking about portability and just ease of use, obviously Nintendo really jumped on Vulkan, for the Switch, especially because obviously power consumption, we'll get into that in a second, but it's really interesting you're seeing Doom, for example, on, the Switch, which obviously you probably can't comment because you may not even know yourself, but I'm going to probably guess, especially because Bethesda have really kind of embraced the whole Vulkan ecosystem. It's just damn impressive that essentially you're getting a tablet. Okay, Doom is running at I think it's at 30 FPS, but come on. I mean, just the fact they're even getting Doom running on the Switch, it's wow. I didn't. If you asked someone 3 months, before the launch, everyone would have just laughed at you. They would have been like, "No way, that's going to happen."
Right, and that's really the reason I think the developer community is, beginning to embrace the new generation explicit APIs. And let's not forget, they're still babies, right? That OpenGL has been out for 25 years. Vulkan has been out for 18 months. So, it takes a while for people to, read the spec, understand it, try it out, and kick the tires, and then get it out into a game. So, actually, the rate of adoption is actually pretty impressive. How quickly people are beginning to adopt it. But the advantages, I think, as people really write to it and take advantage of the new explicit architecture, the advantages are beginning to come through. And one of the biggest ones is, as you say, is the fact we can much more effectively use a multi-core CPU than we can with OpenGL, which had single-threaded dispatch, and Vulkan breaks that bottleneck with multi-threaded dispatch. So many platforms, particularly, as you say, the more mobile type that typically have a less powerful CPU, Vulkan can really provide a big performance boost. And to just loop it back into your original VR question, the other big advantage of Vulkan, because the driver is so much thinner, the latency is less. And for VR and AR, the latency is actually, I would say, even more important than the absolute performance, because there's no point being able to pump a multi-million polygon scene if it's lagging.
Yeah, and more to the point, it can literally cause you to feel nauseous. Like, if you turn left and there's a slight delay, your brain... Because I actually have an Oculus DK2, like a development kit too, and I was doing some experimenting. This wasn't on the channel, it was just kind of on my own accord, and I was doing things like deliberately limiting the frame rate, or, having the frame rate as high as possible. And when I was playing something like Half-Life 2, and it was like high frame rate, it was fine. But when I started to go like where there's latency, I felt like I needed a bucket next to me, to be honest. It's not nice.
Yeah, no, and that's a fundamental problem, and that's not good if we're trying to promote a new technology into the consumers. And the lasting impression they have is that I felt really sick.
No,
that's not good for adoption. And so, yeah, the latency is really the key issue, and Vulkan is measurably less latency than OpenGL.
It must make you smile a little bit, because you probably obviously don't want to comment on this too much, but it must have made you smile a little bit, because I don't know if you're aware, but both Dolphin, RPC S3, which are emulators, they've basically pushed DirectX 12 away, and they've basically switched to Vulkan now because of cross-platform and performance reasoning. I did find that rather amusing, because Dolphin literally just nuked it. I'm not like a big emulator guy, but I was just reading, because I was doing due diligence on this, and I was reading like the Wikipedia articles of what supports Vulkan, and I just happened to notice that these emulators did, and I did a bit more digging, and I was like, oh wow, that's quite funny.
Yeah, right. DX12 is a perfectly good API, and actually it's very similar to Vulkan and DX12 are actually quite similar, and if you can get the performance and latency benefits from both. So for many developers, it does come down to what platforms do I want to support, and if one, obviously DX12 is just limited to Windows 10. So if I want to support multiple Windows versions and other platforms too, Linux and Android, for example, then the fact that you can use one API that's going to give you the good performance and the portability too, it is an obvious win. And I think a lot of the developers are doing that calculus and figuring out the Vulkan is the right answer.
How much work would it be, for example, let's say that you authored a game for Windows? Let's, for sake of argument, say it was something like Resident Evil 7, but it had been created with Vulkan in mind, so it had been built with Vulkan. How much work would it be? I mean, obviously it does depend upon the game, but realistically, do you think that this would allow developers to much more easily port it to Linux? Like, because obviously you wouldn't have compiled the entire engine with DirectX 11 in mind.
It definitely helps. I mean, the back end, if people are authoring directly to Vulkan, then of course it makes it easier because Vulkan's going to be available natively on Linux. But even if they've authored in DX12 and then want to bring it over, the back end rendering for DX12 and Vulkan is close enough that that's not an insanely weird thing to say. You could easily bring a game over from DX12 to Vulkan, and in fact, we're actually trying to make that even easier. I don't know if you've seen one of the projects we have going is we're calling it the Vulkan Portability Initiative.
I had spotted it.
Yeah, and that's kind of addressing exactly that issue. The realization is that, of course, developers want to port. Their ideal world is they can port across any platform with zero back-end reporting. Reducing costs and increasing footprint is something that's good for the developer community. So the number one question we actually get about Vulkan, it typically goes, the conversation typically goes, Vulkan is awesome. I wish I could run it on the Mac. And Mac and iOS, because that they're obviously our key platforms, and we're politically not allowed to run native Vulkan drivers on Mac OS or iOS.
Yeah, because Apple are quite protective, and obviously you've got Metal and all of that stuff as well. So
that's right. So they're invested in their own proprietary API. So the point of the Vulkan Portability Initiative is that we realized that the three new generation APIs, Metal, Vulkan, DX12, are relatively similar. Vulkan and DX12 are very close. Metal is a little bit more traditional. It's a little bit more OpenCL, OpenGL, but even so, they're not too far away. So rather than making developers do that back-end porting, why not define a subset of Vulkan that can be directly mapped easily by a runtime shim library, so you can write in Vulkan and run your Vulkan code anywhere, including Apple platforms. And that's the intent of the Vulkan portability initiative. And it was interesting actually, because we went to our first idea was to create a new hybrid API, kind of mixing up the best bits of Metal, DX12, and Vulkan, creating a portable API. We actually went out with that idea at GDC, which was back in February, and we got some excellent feedback from the gaming community saying, please don't do that. Because three APIs are bad enough. A fourth API is going to make things even worse.
It's going to be too much.
Well, another whole API to learn, to market, to support, to port to. And that was also the right feedback. So we went back to the drawing board and we said, okay, let's not create a fourth API.
Let's not compete with ourselves more.
Right. Well, yes, exactly. And so, but let's create a subset of there is one new generation 3D API that is non-proprietary and designed to be portable, and that's Vulkan. So let's define the portable subset of it that can be run anywhere. And the good news is that they are close enough that it's over 85% of the API is easily mappable onto the other two. So
it kind of reminds me a bit of what Microsoft did with the Xbox One X, because you may be aware of the architecture. Essentially, with the original Xbox One, they had the ESRAM, which is 32 megabytes of fast memory, but with the X, they obviously have so much memory bandwidth thanks to switching to GDDR5 with a high wide bus width and fast memory. All they essentially did was drop the ESRAM and then just map the ESRAM memory addresses to GDDR5, and it basically is the same. So essentially they're kind of just getting around the problem.
Yes. Backwards portability, is a good thing to do. You shouldn't force the developers to change code unnecessarily. It's just friction in the market.
It's kind of weird as well, because, I was actually doing some further research, and obviously we've had Ashes Singularity, which is now, I believe it's Escalation, has the Vulkan backend, and now you've got Wolfenstein 2, CryEngine, even Dell have actually, become members of Khronos. So it's like, you could kind of feel the train, and one of the things that just made me smile way too much, and I was like, yeah, this is the point where you're a geek. Someone actually, I think it was from id, I believe it was one of the guys from id, they actually released a kind of a patch / a version of Quake, I believe it's Quake 1, I'm pretty damn sure it's Quake 1, and it was actually Vulkan. And you're like, wow.
Right.
I don't think you need it for performance reasons, but it's damn cool.
Yeah, no, exactly. It's, and it's partly because of the performance, partly because of the portability, but also, and we were being careful at the beginning to not try to trick people that Vulkan was trivial, because that there is more complexity to Vulkan in that you have more explicit control over the GPU. Therefore, you do need to understand what the GPU is doing. But what we're actually finding, and we are, in the beginning we were saying, be careful because OpenGL is much simpler than OpenGL. Vulkan is going to take a little bit more to learn. But we realized that we were actually over people, because what's actually happened is that people actually really like the Vulkan API, even though there's more code and there's lots of code at the beginning to set things up. So there's quite a lot of code you get to before your first triangle appears on the screen. But there's a good reason for all that code, because the whole point of Vulkan is you're not having to fiddle things. Once you're in the fast loop, you set things up before you start rendering everything, so the rendering can go at maximum performance without waiting for anything. And people actually really like having direct control over the GPU.
Rather than having this massive API, which is essentially sitting there and doing all the memory management for you. Now you can, because the name eludes me, but it's obviously where you have a resource binding. So essentially you can put almost like a bunch of resources into, I can't remember what the name is. It's really bugging me. The name's right on the tip of my tongue. But with Vulkan, obviously you can create essentially resource lists, right, and pull those in. So you can have, for example, shaders, geometry, and then those can be pulled in and out per scene. And it's just a much more natural way, I guess, for developers to utilize that.
That's right. That's right. And you get to control how you use the GPU in a way that suits your application rather than a large, thick OpenGL driver. Honestly, trying to make good heuristic decisions, but it's never going to be exactly the right decisions for your particular app. So, and we've
descriptive sets. Sorry, that was
descriptive sets. Right. Yeah.
That was just driving me nuts. Sorry.
Well, I've got an excuse. It's Monday morning. You don't have that excuse.
Mine is I haven't had enough coffee.
But it's got to the point where now people have kind of realised that the boilerplate code at the front isn't. There's a good reason for it. It's not a problem. People are now saying, well, if I'm going to teach someone, or if I'm a student and I want to learn 3D, should I use OpenGL or Vulkan? It's actually an interesting question. And I think the good answer, actually, Tom Olson, who's the chair of Vulkan, said it the best. I think he's saying, if you want to learn the fundamentals of 3D, Vulkan is probably not the right place to start, because you're going to get so into the GPU management quickly. It's going to distract you from learning about matrices and stuff. But if you want to learn how to drive a GPU, if you already understand the fundamentals, then you actually want to learn how to drive GPU for a real application, then Vulkan is absolutely the kind of place to go to learn, because it is the most portable abstraction over a modern GPU architecture. So it's actually people, and it's good to see that people are kind of realizing that.
What I think was really insane, I saw there's a game called VainGlory, which is a MOBA game,
mm-hmm.
And I saw that they also conducted a kind of seminar. PDF is available. I'll try to remember to link all of this stuff, by the way, in the video description for viewers.
Mm-hmm.
And
sure.
I remember that they actually released a document, and you can see that memory footprint and power consumption went down dramatically. They were saying, I think it was like 5% power usage reduction, which doesn't sound much, but it damn well is. When you're playing for several hours of a game,
mm-hmm.
that's pretty. Because also, of course, you're seeing less power consumption, which naturally means less heat production.
Yep.
But on top of that, the actual file size, and that would be the APK, and as well
yep.
as the actual memory footprint, got drastically reduced. And one of the reasons they cite it is because ETC only stores 3 color channels. That's RGB, obviously. And so they required an additional texture on top of that. But obviously, ASTC, which is for Vulkan, it stores alpha as well. So when they actually combined all of this stuff, and they said that, it wasn't like they wrote the game from the ground up. It was a port. So you can imagine that people are getting these fantastic results in just 18 months.
Right.
With a new API. It's just insane.
Yes. It is. It's good to see that all the hard work that the working group has done is beginning to pay off for real apps.
I think. Sorry.
Well, I was going to say, and then to loop it right back into the VR, your original VR question, because you mentioned OpenXR, and then we mentioned which is for portable virtual reality and augmented reality, and then we mentioned how Vulkan was good for virtual reality. I mean, and perhaps to make it clear, the Vulkan and OpenXR, they're not competing. Of course,
No.
an application needs both. Vulkan is doing the 3D rendering, that's as we've been discussing. OpenXR is taking care of everything else in a AR or VR system. So the positioning of the HMD, where you're looking, hand tracking, controller tracking, soon things like eye tracking and body tracking, whatever kind of input sensors, and how you process those in real time, is being handled by OpenXR, and that sits side by side with Vulkan that is actually driving the output 3D rendering. And there are connections between the two. So an application who's using both of these will be able to interrogate OpenXR to understand things like what's my frame rate, what's my field of view, what's my geometric correction, that I need to apply to my rendered images, and they drive that all down through Vulkan, but they get all the parameters on how to drive Vulkan from OpenXR. So the two kind of are a matching pair, and you would use both in a VR and AR app.
Which essentially, I mean, basically they're almost like a married couple. Like one kind of needs the other one to survive, I guess you could say.
Yes, no, exactly, and they're designed to complement each other and fit together really well.
Would you say that now? I guess you could answer this in both NVIDIA and Khronos, but one of the big things at the moment, for example, let's say you've got a 1440p display. Let's take VR out of it because that adds even more complexity, like what your frame rate is and all the stuff. But let's just say you've got a 1440p display. You can make a very good argument that, for example, the GTX 1080, let alone the TI/Ti, whatever you want to call it. I don't know what you refer to the TI/Ti as. Do you call it GTX 1080 Ti or Ti? It's like a big argument across the internet on that one.
Well, I call it TI.
Fair enough. Well, anyway, whichever way, if you've got a 1080 or above, you don't need more than one of those quite often for a 1440p display, unless obviously you're playing like a competitive shooter and you need like 144 hertz or whatever. So, I mean, would you say that multi-GPU, because AMD, obviously you can't comment on what AMD are doing, but AMD are not retiring Crossfire, but they're kind of putting it on the back seat thanks because of MGPU, it's obviously multi-GPU in the same system because of modern app is. So do you think that multi-adapters are still something that high-end gamers and, of course, naturally developers, because ultimately developers are going to do what gamers want, because obviously they want to sell the game. So do you think that it's just a lot more work to implement now, especially on Vulkan? Because obviously Vulkan has pretty good multi-GPU facilities. So do you think this is like something that NVIDIA are also going to be kind of considering, and also I guess Khronos as well?
It's a good question. I think from Khronos' point of view, definitely want to enable multi-GPU because there is market demand. Of course, though, in the end, it's not us that ships stuff. It's the GPU vendors like AMD and NVIDIA. I think NVIDIA, we definitely see the need for multi-GPU systems. However great our greatest GPU is, two of them are better.
This is true.
And they're always use cases, not just in the gaming space, but potentially in the professional space too, where people want that level of extra performance before it's possible in a single GPU, and that's like a persistent adoption curve. There's always people that want to be that one step ahead by using multiple GPUs. I think though, the desktop vendors, we are rationalizing a little bit to make the effort commensurate to the return. So, for example, Vulkan, we support like 80% of all the common use cases. We can support multiple GPUs from the same vendor, but we don't support mixing and matching an AMD with an NVIDIA, and we don't, at least yet, and we haven't had too many complaints. We don't support like an NVIDIA GPU rendering the same screen as the embedded AMD or Intel integrated GPU, because we found that it is a relatively small slice of the market that wants to use two GPUs, and it's an even smaller slice of that small slice that wants to mix different vendors. So at the moment we're focusing on a rationalized set of configurations that we support.
Yeah, I mean, for example,
and Vulkan is focused on those that are actually going to ship in the market in a meaningful way.
Yeah, I mean, one of the problems of cross-vendor, for example, I mean, it's cool in that it sounds great, but let's say for the sake of argument, you have a GTX 1070 now, and then realistically, you're not going to go out and buy like a Vega 64. Because, yeah, okay, it's faster, but it's not that much faster. So you're either going to buy another 1070 for like SLI, or you're just going to wait for either the new range of graphics cards, whether that's Volta or, Bob's GPU, or, it doesn't make sense really. The only time that you can really see that as an even argument, for me anyway, is like, let's say you've got like an R9 290, and then you buy a GTX 1070 once again, then you can kind of see that. But even so, you've got other questions and concerns as well. Like, obviously you're going to be sucking up extra power and heat, and it's probably not really worth it.
Right. And, it does come down to, from the vendor's point of view, to test and figure out all the issues that you have when you plug two different vendor boards together. That's a lot of effort, and not many people are asking to use it. And it comes down to, with two different vendors, the support and integration becomes much more tricky. And of course, we want to provide a good experience. And if, we try to do something and end users get configuration problems and performance and stability problems, then in the end, we haven't done the right thing, even for those consumers. So I think Vulkan is taking the right approach, and I think it reflects the reality, that yes, we want to enable people that absolutely want to plug two boards together and take that extra step, but we don't have to support all these more fringe configurations. I think that's the right trade-off.
Well, personally, I don't know anyone who really wants to do it. I mean, I often get questions of, hey, I've got like a GTX 970 and I'm thinking of buying a 1070. I can't crossfire them. Also, I put them in SLI, can I? Like, those questions you're going to get from the less technically literate occasionally.
Right.
But you're never going to get, at least I've never got someone who said, hey, I happen to have like this i5 CPU that's got, an Intel blah, GPU built in, iGPU. Can I run that, and shave like two frames per second off of my 4K FPS? No one's going to do that. So the only time you could actually possibly make an argument is if you started to use it somehow for like GPU physics or maybe some lighting effects or some AI. But it's so much work for the developer. I just don't really see it as like a viable alternative, like you said.
Right. Yeah. I think it's 80-20 rule.
Yeah, speaking of the desktop space though, I mean, obviously AMD, to their credit, and I'm really happy to have released the Ryzen set of processors. You've got 8 cores, 16 threads, obviously with the Ryzen 7. Also, I'm very happy you've got Coffee Lake on the horizon, 6 cores, 12 threads. But do you feel that this is going to necessarily improve games in terms of the frame rate, or do you think, especially from the API side of things, or do you think instead they're going to be better off just saying, well, a couple of fast cores is probably enough in the short term, so this is going to more lend itself to perhaps better AI, pathfinding, physics, and other such tests, or do you really think that this is going to be needed to keep pushing the frame rates?
I think the advances in CPU multi-threading, it has got to be a good thing. I think it's kind of chicken and egg. It's true that many of the games don't take advantage of more than a couple of cores, but that's because that capability hasn't been widely, cheaply. Once the hardware is truly pervasive, where you can have meaningful multi-threaded performance on a low-cost machine, then the developers absolutely learn how to take advantage of it. And that's one of the big advantages, as we were saying before, with the new generation APIs, is we've broken that single-threaded bottleneck between the CPU work preparation and the GPU work execution. So the APIs like Vulkan can take full advantage of that. So no, I think it's a good thing. It may take a while because multi-threading programming is not trivial. So you can't just do it on a whim. You have to kind of plan it out. But if there's real advantages to be had, and I do believe so, then the developers will take advantage of it.
Would you? I mean, this is I guess a very similar topic question, but I guess this is from both NVIDIA and the Khronos perspective as well. Currently, if you're watching this in the distant future, it might be a bit different, but currently you've got DDR4 and PCIe. With NVIDIA side of things, obviously you've got NVLink for high performance type of computing, but that's not something that the average person is going to have in their PC, obviously.
No.
Do you think that when DDR5 and PCIe 4 are introduced, we're going to see better performance in terms of graphics? Is this like an issue with multi-GPU or Vulkan at the moment, or do you think that at the moment systems aren't really held back by bandwidth, but once we get that additional bandwidth, the floodgates are going to open, or were you going to see like improvements in latency because obviously higher bandwidth, better throughput might actually improve things for VR and whatever else, or do you think it's not really going to be that big of a deal yet? Instead, it's more future-proofing? Especially now we've got like higher processor cores as well, which obviously suck up more bandwidth.
Bandwidth is always a bottleneck. Bandwidth is always, almost always the bottleneck. Seriously, and a lot of the algorithms and the ways of using these various APIs are at their core figuring out how to effectively use the memory hierarchy, because bandwidth in the end is typically the bottleneck. So more bandwidth is going to give you better performance and open up the developers to use the APIs in more generalized, powerful ways to generate better effects, more sophisticated rendering techniques that will be enabled because of higher bandwidth that can be sustained. So we can drive things at interactive frame rates. So bandwidth is one of the absolutely essential key ingredients. There's no point in having more processing power without more bandwidth. The two go hand in hand. And memory bandwidth is Moore's law has been going up so fast, and now Moore's law might be running out, but the parallel architectures, particularly in GPUs, continue to keep that rapid pace in processing performance going up a very steep curve. Memory bandwidth has been lagging because it's much more difficult. It's laws of physics. We're trying to shovel more electrons across bigger distances, going out through the memory hierarchy, and so it's in some ways it's a more difficult problem. So any time we get a lift in bandwidth, we can unleash more of the processing power.
I guess it's also kind of I guess this is kind of a two-part question again, but when you think about it, you've also a processor. By a processor, I mean CPU, is sending obviously instructions to the GPU, but obviously the GPU needs to communicate back, and especially when you're dealing with compute type of tasks. But on top of that, if you go to a different area, for example, most GPUs now have 4 gigabytes or more, most have like 6 or 8.
Yep.
But look at texture sizes, and if you can't transfer that huge texture, that 4K texture or whatever, fast enough, you're going to get frame rate stuttering. So even if you've got all the GPU power in the world, it doesn't mean much if you can't shunt it across the system. Yes,
that's right. Having good data is no good if it's not in the right place at the right time, and that means you need the bandwidth, both in and out of the various memory subsystems and between GPU and CPU, as you say. So bandwidth is good. Bandwidth is enabling. Give me more bandwidth. I love bandwidth.
I guess this is an NVIDIA and Vulkan question as well. It was originally, sorry, a Khronos question as well. It was originally supposed to be a Khronos question, but now I guess kind of it makes sense for NVIDIA because obviously you've got somewhat of a vested interest in the mobile sector of NVIDIA. So that's putting it mildly. Do you think that HBM as a whole is going to be important in the short term for mobile devices? By which I mean like laptops and so on, not like obviously a cell phone. Because of the lower power consumption, or do you think in the short term, at least like the next 12 months, it's just too 24 months, it's just too expensive for regular customer grade products? Because, you know, from what I understand from Jensen Huang, he said something about that's one of the reasons that Volta as well was delayed on desktops, because it's just too expensive at the moment, because obviously they're putting like 16 gigabytes or whatever it is of RAM on like on a Volta GPU. So do you think that's true, even though the memory bandwidth on HBM is, you know, pretty damn awesome for the power consumption, you know, return on investment in that sense is amazing, but return on investment is in like pennies in your wallet, not so great.
Right. Yeah. It's not something I track personally, but I know that, you know, we do track all of the different memory technologies, and it is exactly as you say. It's not just a raw performance equation. It is, it has to be affordable, and you know the price performance has to be there. And I think I would agree. In the very short term, I think, you know, things like HBM are a little bit too expensive for many of the mobile use cases.
Do you feel that with the open nature of Vulkan, and do you feel that in a way you kind of have almost like a slight disadvantage to Direct3D 12? Because developers, I guess what I'm saying is with Direct3D 12, you can't really go wrong in terms of like, you know, the ecosystem, but with Vulkan, it can feel, because of not only the portability, but just the sheer number of tools. You know, we've talked about, you know, the portability initiatives and, you know, things to help with, you know, virtual reality and compute and so many different areas. Do you think it can be a little bit overwhelming almost for developers? And that's one of the reasons you guys are putting on so many seminars and so much help is available.
I think that's a great question. I think there's a couple things that kind of inspires. So first of all, as you said earlier, the DX12 is a pretty good API. There's you know, it's well designed, and of course Microsoft's great strength is that, you know, they are also providing good tools, and you know, it is the native API on Windows 10, which gives it kind of the home team advantage on that significant platform. So there's a number of things that, you know, if Vulkan, but you know, the big picture is competition is good. I think it's good for DX that Vulkan exists, and it's good for Vulkan that DX exists. I hope we, you know, both push each other forward faster than, you know, if we had no real competition. So I think it's good for the industry, good for everyone. But if we are going to compete, you know, in a loving way with DX12, we'd absolutely need to realize that we are not just shipping an API specification. We need to have a fully formed ecosystem. We need to make sure that the tools are there, you know, the compiler front ends are stable, you know, people can upgrade their toolkits, get it installed easily, everything continues to work when they upgrade. All these, you know, real world but vitally important issues, you know, we don't drop those, because if we don't get that right, then, you know, DX12 will be much easier to use and people will use it. And because though we're a cross-platform open standard, we will achieve that in a different way than Microsoft. Microsoft has the money and the investment, you know, to do it themselves. We need to be much more engaged with the community. A lot of the stuff will be open source, and a lot of the open source community members will help us, you know, make sure that the ecosystem is there. And you know, and I think it's good to have kind of both threads. But the other side of that, though, is that OpenGL always had the problem that there wasn't a and I'm going to apologize in advance to the Linux community here. I mean, OpenGL never had a tier 1 platform where it was the native API. And so OpenGL never had a home team advantage on a high volume consumer platform. But that's not true of Vulkan. Vulkan is actually the native API for Android. Okay, that's mobile, not desktop. But no, it is worth remembering that Android is the largest volume platform in the known universe.
I was going to say it's not a small platform. That's a pretty big win.
Yeah, exactly. I know it's I think it's up to 85% now. The mobile market is now Android globally, and no, that's Vulkan. We're transitioning. We're in the middle of the transition from OpenGLES to Vulkan, and OpenGLES is not going away. But in a year or two, I think most Google like to use the high fidelity 3D games are going to be on Vulkan, and that gives us a significant home team advantage on the largest platform of all. We'll fold into people's calculus, saying, okay, well, I want to address all these different platforms, and they won't be able to make, but OpenGL's not supported by the platform vendor on anywhere, so I can't use it. It's not true with Vulkan. I think that's going to really change people's perception.
Is there anything you dislike at the moment about Vulkan OpenGL? So that could be the documentation side of things, it could be a technical aspect. Do you feel that there's something that you kind of need to improve on, or I mean, obviously it's kind of a negative question, but do you feel sometimes that you kind of wish that you'd maybe, something could just be changed overnight?
There's definitely room for improvement. I wouldn't change anything on the design of Vulkan. I think the Vulkan design has been well considered. I mean, there's minor bits and pieces that we will polish up over time, but that's inevitable. There's nothing wrong with the Vulkan API design. Where we absolutely need to put more effort is in the robustness of the ecosystem. And we have, you look at the PowerPoint level, we have front ends for HLSL, but the feedback we're getting from the developer community is every time we have an upgrade to that front end, their shaders stop working, and that's no good. We need to have more regression testing in the front end compilers for GLSL and HLSL. We need to have more tools to optimize the SPIR V code size. There's all these mechanical things that have to work, and we're close. We've made awesome progress in 18 months. I'm not saying it's not coming together, but we really need to put more effort into really making sure that it comes together. And we compete on a stability and richness of the tools ecosystem. With the X12, that is our competitor. We need to get to that level of professionalism, and I think we can do it. And I think over the next few months, you'll probably see some initiatives from Khronos that are reaching out to the developer community to make sure we're working all effectively together as a community to make that happen.
So, I mean, once again, just looking at the Mad Max performance, the developers were incredibly happy, and they even said that given the age of the API, they were actually startled that they didn't get many problems. I mean, they didn't rewrite the engine from the ground up, obviously, because it was only a port. I don't mean that in a disrespectful way, but still, even if you take the median of 150% performance increase, that's damn impressive. And they didn't really get that many issues. So I think, Vulkan, I mean, it's not even has potential, because that statement is doing it a grave disservice, but it's obvious that, everyone who's worked on this, it's a labour of love more than anything else.
Right. People care. Yeah, it's true.